Alright, this is going to be a quick video to help you out with 11C. We're going to talk about central angles. We are going to talk about how to find the area of a regular polygon. And we are going to talk about how to find the area of the shaded region. So, starting out with the first part. The formula to find a central angle is to take 360 degrees and divide it by the number of sides there are in a shape. So, if I were doing problem number 1 and I wanted to find the central angle for a 12-sided shape, I would take 360 divided by 12, which turns out to be 30 degrees. Being able to find a central angle is important, and also being able to know what a central angle looks like is important, especially once you get into regular polygons. So, in this shape, which is a hexagon, so it has 6 sides, we can actually divide it into not just one, well, let's go smaller, not just one, but 2, 3, 4, 5, 6, so 1, 2, 3, 4, 5, 6 central angles. Keep in mind this is one giant central angle down here. So if I wanted to find the measure of just any one of these central angles, I take the 360 degrees here, divide it by 6, and that turns into be 60 degrees for each of these angles located at the center of this hexagon. So if I were doing problem over here, I think it's number 5. So problem number 5 says find the measure of angle EGD. EGD right here is in fact a central angle. So since that's a central angle, that answer is 60 degrees. Now if I look a little bit closer and I were to go down to number 7 where it says EGH, angle EGH right here is just half of a central angle. So since this whole angle right here is 60, if I just want this one, it's going to be 30 degrees. This is important because you're going to need these later on for regular polygons. So, just to summarize, in order to find a central angle, all you have to do is take how many sides it has and divide that with 360. So down here, when I get to a dodecagon, number 13 says find angle TWU. If I go from T to W to U, I can see that this is in fact a central angle. So if I want to find that one, I take 360 divided by the 12 sides it has, which then gives me this one angle right here at 30 degrees. If I wanted to go a little bit further and just figure out this side of that 30 degree angle, I could take 30 divided by 2, and then I have 15 for that one. Alright, so I'm going to move on to area of regular polygons. So down here, problem number 20, we have a regular polygon, and it's going to be our goal to figure out the area of this. The formula we're going to use is take the perimeter times the apothem and then divide by 2. So if I take a look at this shape I have, I know I'm going to need the apothem along with the perimeter before I get the area. So if I take a look, this is the apothem because by definition the apothem hits the middle of a side. It breaks up the side into 2 equal pieces. So my apothem is definitely 6. So if I keep looking, my next goal is to get the perimeter. I know I could get the perimeter if I could figure out this entire side length, because then I would take this side length right here and just multiply it by 3 since there are 3 sides. So to get the side length, I'm going to first just find the length of this piece, which I can do using Pythagorean theorem. So if I calculate really quickly, turns out by taking 12 squared minus 6 squared, you get that answer, which is 108, and then you square root it. You would find out that that little length right here is actually 10.4. So since this is 10.4, this would be double 10.4, so your side would actually be 20.8. So if I want to find the perimeter, I'm going to take the 20.8 and multiply it by the 3 sides. So to get my final answer, my perimeter would be 62.4 up here. Now that I have, there we go, my apothem and my perimeter, all I'm going to do is multiply my perimeter and my apothem. Ooh, sorry, my picture just came back. Sorry about that. So I'm going to multiply my perimeter and apothem and divide it by 2. So if I take that 62.4 multiply it by the apothem of 6, and then divide that by 2, I would get a final answer for my area of 187.2. And then I'm done with that one. So the key to finding the area of a regular polygon is two things. You need the perimeter, you need the apothem, then you multiply them and divide by 2. So if I go a little bit further, jumping down to problem number 1 on the day 2 worksheet, if I take a look at this, my goal is to find the area of the regular polygon. So before I do that, I'm just going to look. Do I have perimeter? Do I have apothem? Because if I do all the hard work, I don't have to go through it, I have my pieces. Since I have this side length, I can just take that times 5 in order to get the perimeter. So 6.9 times 5 is what my perimeter would be, so 34.5. That's perimeter. If I look at the apothem, again the apothem goes from the middle of the shape to the center of a side at a right angle. Well, I've got one drawn in for me, it just goes this way, so my apothem right now is 4.8. So to get the area, I'm going to take the 69.5, multiply that with the apothem of 4.8, divide that thing by 2 to get my final answer. Now the only way I can make this a little bit trickier on you is down here at example 3, where I only give you one piece. If you take a look at example 2, if I clear off what I did, you see how you had two values. You had a side length and the apothem. That's best case scenario. If I do not give you two pieces, you're going to have to work to find what you're missing. So if you stick with your game plan of you need perimeter, you need apothem, and just kind of look at what you have, we can come up with a plan to get this involving using what we did back here with getting a central angle. So if we take a look at example number 3, I know right now, since 9 is the length that goes to the middle of that side, 9 is my apothem. So the only thing I have to do before I get area is find perimeter. And I also know that finding this little length right here would help me get perimeter, because I could take it and I could double it to get this side, and then I can take that times however many sides I have, which in this case is 6, to get the perimeter. So what I'm going to do is I'm going to go back and I'm going to draw in a central angle. Since this shape has 6 sides, the central angle would be found by taking 360 divided by 6, which means this angle right here is 60 degrees. Now that's not actually the angle I want. The angle I want is this purple angle right here, which is going to be exactly half of the 60 degree angle. So if I were to go right here, I now know this angle is 30 degrees. This is how it's going to help me. If I take a look and we get rid of my central angle at this point, remember, let me fix that. I know my apothem is 9, so maybe I'll go this direction. This one, 30 degrees, because that one was as well. Okay, so at this point, I have my apothem. I'm going to just slide this over, and we'll just find this side of it instead, not a big deal. Okay, so then my 9 doesn't get confusing. So at this point, all I need to do is get x. If I take a look, I cannot do Pythagorean theorem at this point, but since I have my angle now, I can say x is the opposite side. I know 9 right now is my adjacent side. Yes, you may, Maddie. Sorry. So I have my opposite, I have my adjacent side. So we're going to do tangent. We have 30 degrees. Opposite over adjacent. This is going to be multiplying. So if I take 9 times the tangent of 30, you will find out that this little length for x is 5.2. So my opposite side, right here, this little piece, 5.2, which means my entire side, right here, is going to be 10.4, which means when I want to go to get my perimeter, I'm going to take 10.4 times the fact that there are 6 sides in this shape. So to get my final answer, if I take 10.4 times 6, the perimeter is 62.4. Now that I have my perimeter, now that I have my apothem, I'm going to do the same thing we did before, which is take your perimeter times your apothem divide by 2. There are a few more videos online posted in the Friday folder. I think it says Friday, May 17th, that you can look at, that are examples from the back side of the Day 1 worksheet as well. Moving into the last thing, area of a shaded polygon. So these are more of a process. So I'm just going to start out with problem number 3. Problem number 3, your goal is to only get the answer of the shaded polygon. If I only want this part, it's kind of like I have a square, but I'm missing the circle that's located inside of it. So if I just want to get the area of this shaded polygon, what I'm going to do is I'm going to start with getting the answer for the entire square, which I could do because the base and the height are 22 on it. And then from there I'm going to subtract off the area of the circle, which I can do because all I would need to calculate the area of the circle is the radius. And I know the radius because this entire length is 22, so that means just the radius right here is going to be 11. So if I were to take 22 times 22 to get the area of the square, and then take the radius squared times pi to get the area of the circle, then once I have both of those, subtract those answers, that would be the area for the answer in number 3. Problem number 1, a little bit different because I'm adding 2 shapes up. I would have to calculate the area of this triangle, which I could get by taking base times height, divide by 2. And then I would have to calculate the area of this shape, which is a circle, but halved, because I only have half of the circle. So to get this one, I would take its radius squared times pi, and then I want to keep just half of the circle, so I divide by 2. So my goal would be to take the area of this triangle, and then add it to the area of this half circle. So if I just look for the pieces I need, which sometimes it looks a little bit harder than it is, so maybe drawing them in can help. I know that all of these lengths marked in red right here are 10, which means this length is 10, which means this length right here is 5. So the radius on my circle is actually a 5, so I could go through and calculate a half circle I need down here. If I were to go back and take a look at this a little bit more, in order to find the triangle, I need its base, which I have. It's 10. I would also need its height, which I don't have, but I can get. The height for that triangle would be located right here. And if I take a look, height meets the base at a right angle. We already talked about the fact that this side is 5. So if you were to focus on just this triangle right here, which is a right triangle, and knowing the fact that we have the hypotenuse and one of its sides, you could actually use Pythagorean theorem to calculate the height. Once you know the height, you're going to put it right there, and then do your calculation for your triangle. Once you have that answer, don't forget to add it back to the answer you have for your half circle. So some of these are just more of a process. Problem number 4, if I wanted to find the area of that shaded region, I could do rectangle minus triangle. And depending on the problems you're doing, like down here, this one also, square minus triangle, you just have to make sure you put them in the right order. Problem number 5, the biggest shape is a rectangle, so I'd start out with the rectangle, and then from it I have to basically remove 6 circles. So to do that a little bit quicker, if I were to just find the area of one of those circles, and then multiply that answer multiplied by 6, this would represent the area of all of these circles that I need to subtract from that giant rectangle. So hopefully this helps. If not, I'm around next week and you can try to stop in, and we'll just see how it goes from there. Good luck!